Hey kids, welcome to section 7.5 variation functions. Today we're going to learn how to recognize and solve direct, joint variation problems, also inverse and combined variation problems. So of the four types, we're going to start with direct variation. A direct variation equation can be expressed in the form y equals kt. In this equation, the k is called the constant of variation. Basically tells you how two things are compared, how they are related to each other. Since it's the same every time, it's called the constant of variation. So the wording on these problems are going to look like this. Y varies directly as x if there is some non-zero constant k, such that y equals kx, and k is called the constant of variation. So we have the phrase y varies directly as x, and that's the equation y equals kx. All right, so let's see how these look. Number 1a, if r varies directly as t and r equals negative 20 when t equals 4, find r when t equals negative 6. So the first thing we're going to do is take the very beginning of the sentence, if r varies directly as t, and we're going to write the equation r equals k times t. So we're going to take the letters that are in the problem, r and t. Those are kind of like our x and our y. And then we're going to figure out what our k is. Now to figure out how the numbers are related, we're going to use this first bit here, r equals negative 20 when t equals 4. So we're going to substitute in negative 20. We're going to substitute in 4 for t. And then we're going to figure out what k is by dividing by 4. So this is going to tell us that k equals negative 5. Now we're going to take this constant of variation when we're going to write our equation. R equals negative 5t. So I just took the generic equation, I subbed in the constant of variation and got r equals negative 5t. Then we're going to figure out what r is when t equals negative 6. So we're going to figure out what r is when t equals negative 6, and we get r equals 30. 5 times negative 6. Okay, so they're always going to tell you how they're related. In this case, it's directly. They're going to give you one situation where you know all the values, and that's going to help you find the constant of variation. And then they're going to have you use that to find a new value. All right, here's another one. If y varies directly as x and y equals 15 when x equals negative 5, find x when y equals negative 21. So here's the first part, y varies directly as x. So we're going to write y equals kx. Then we're going to find the part where it gives us both an x and a y. That's y equals 15 when x equals negative 5. So I'm going to substitute in 15 and negative 5. And then I'm going to solve for k by dividing both sides by negative 5. And that's going to tell us that k equals negative 3. All right, so now we're going to take that equation or that constant of variation and substitute it back in. So we get y equals negative 3x. Now we're going to take our last bit of information, find x when y equals negative 21. So now we're going to substitute negative 21 in for y, and we get negative 21 equals negative 3x. We're going to find x by dividing by negative 3. That's going to tell us that x equals 7. Okay, so that's called direct variation. These types of real life situations are when the value of one variable increases, the value of the other variable also increases. Or as one goes down, the other goes down. So, for instance, the more food I eat, the more pounds I weigh. The less time I spend on the treadmill, the less pounds I'm going to lose. Something where they're the same. The second type of variation equation is called a joint variation equation, and this occurs when one quantity varies directly as the product of two or more other quantities. So we're going to have wording like y varies jointly as x and z, and our equation is going to look like y equals kxz. So we have that constant of variation again that we did with direct variation. We have the same constant for joint variation. So here's our first problem. Suppose y varies jointly as x and z. Find y when x equals 9 and z equals 2. If y equals 20 when z equals 3 and x equals 5. So we're going to use the first part to write our equation. Y varies jointly as x and z. So that's y equals kxz. Then we're going to look for the information where we know everything. So here we have y, z, and x. So I'm going to figure out what k is. So y is 20 equals k times my x is 5 and my z is 3. Well, now I can simplify the right side. 20 equals 5 times 3 is 15k. Divide both sides by 15. I can reduce this fraction and get 4/3. So now I can take that and I'm going to write my equation y equals 4/3 xz. Then I'm going to use the last piece of information, find y when x is 9 and z is 2. So y equals 4/3 times x, which is 9, times z, which is 2. So let's see, this is going to give me 36 and 2 is 72 over 3, which is going to be 24. So y is 24. All right, let's do the next one. Suppose r varies jointly as v and t. So r equals kvt. Find t when v equals 2 and r equals 28 if r equals 40 when v equals 10 and t equals 4. So we're going to use the last bit to write our equation. R is 70 equals, I don't know, k, my v is 10, and my t is 4. So we simplify the right, 70 equals 40t. Divide both sides by 40. That's going to give me a t of 7/4. No, a k. Ooh, sorry, kids. That's a k. Ooh, that's really bad. Let's fix that. That is a k, and this is going to be a k. All right, so this is k, and this is k equals 7/4. All right, so now we're going to write this equation. R equals 7/4 VT. We're going to use the last bit of information. Find T when V equals 2 and R is 28. So 28 equals 7/4 times V, which is 2, times T, which is what we're trying to find. Sorry, my goodness. My writing is not up to par. Okay, so let's scoot down a little bit here. So let's simplify the right. So we got 28 equals 7/4 times 2 would be 7/2. We can multiply both sides by 2/7. And so we get t equals 8. All right, so the first one was joint variation. The second one was the first one was direct variation. The second one was joint variation. Now we have inverse variation. So inverse variation is when you have two quantities and their product equals a constant k. So we have y varies inversely as x. Now, there are two different ways you can show inverse. There's xy equals k, or I prefer y equals k over x. As long as your x doesn't equal 0 and your y doesn't equal 0, then you can find this relationship inversely between two quantities. So letter A, if A varies inversely as B, and A equals 28 when B equals -2, find A when B equals -10. Okay, so A varies inversely as B. A equals K over B. So again, we have direct where it's A equals KB, and we have inverse, which is A equals K over B. All right, if we look now, this information here is going to give us our k value. Our a is 28 equals k over b, which is -2. I can multiply both sides by -2, and that gives me k equals a -56. Well, now I can take that and I can write my equation. A equals -56 over b. And I can use my last bit of information, find a when b equals -10. So a equals -56 over -10. That gives me a equals 5.6. Since it's a nice decimal, I can leave it as 5.6. If it wasn't a nice decimal, like for instance it repeated, then it would be best to leave it as a fraction. All right, letter B. If x varies inversely as y and x equals 24 when y equals 4, find y when x equals 8. So our beginning sentence here, x varies inversely as y, x equals k over y. Okay, it says x equals 24 when y is 4. So 24 equals k over 4. I'm going to multiply both sides by 4. And I'm going to get k equals 96. So then I'm going to take that and I'm going to say x equals 96 over y. I'm going to use the last bit, find y when x equals 8. And I'm going to say 8 equals 96 over y. Well, it looks like if I put this 8 over 1, I can cross multiply. And I get 8y equals 96. Divide by 8. And you get y equals 12. All right, so that's the third situation, inverse variation. We have one more. This one is the combined variation. Basically, the combined variation occurs when one quantity varies directly and or inversely as two or more quantities. So it's kind of like direct and inverse plugged into one. So suppose f varies directly as g and f varies inversely as h. Find g when f equals 18 and h equals -3 if g equals 24 when h equals 2 and f equals 6. So the beginning sentence right here, f varies directly as g and inversely as h. So f varies directly as g is f equals kg. If I want to now throw in the inversely as h, inversely means put it in the bottom, so I can put it over h. So f equals kg over h. Looks like the second half of my sentence is going to help me find my k. So my f is 6 equals k times g, which is 24, over h, which is 2. So now I can either multiply both sides by 2, or I can simplify the right side and get 6 equals, well, 24 divided by 2 is 12k. Divide both sides by 12, and I get k equals 1/2. It's kind of weird that you get a fraction, but it's totally fine. F equals 1/2 g over h. So now we're going to use the rest of the problem to find the answer. So we're going to find g. Let's see, f equals 18. So 18 equals 1/2. We're trying to find g, and our h is -3. Okay, I'll show you a different way to go about solving this. I'm going to put a 1 underneath, and I'm going to cross multiply. So 18 times a -3 is -54 equals, and 1 times a half g is a half g. I can either at this point divide by a half, or I can multiply by the reciprocal, 2 over 1. And that's going to give me g equals -108. So be careful. There's some interesting, tricky math in there. Watch your signs, watch your fraction bars. Okay, part B. Suppose P varies directly as R and P varies inversely as T. Find T when R equals 10 and P equals -5. If T equals 20 when P equals 4 and R equals 2. All right, so P varies directly as R. So P equals KR. And P varies inversely as T, means that T goes in the bottom. Okay, so we're going to use the second half of the problem. It tells me that P is 4 equals K times my R is 2 over my T, which is 20. So I'll cross multiply here, or multiply by 20. So that gives me 80 equals 2K. Divide both sides by K. No, not K, 2. Divide both sides by 2. And that gives us a K of 40. So now I can take that and plug it back in. P equals 40R over T. Then we can use the rest of the information. Find T when R equals 10 and P equals -5. So -5 equals 40 times R, which is 10, over T. Okay, so why did that bar go all the way over? Sorry. Okay, so let's see. To solve, I'm going to simplify the top. So -5 equals 400 over T. I'm going to put a 1 underneath the -5, and I'm going to cross multiply. So -5T equals 400. Divide by -5. You've got T equals -80. So be careful. There can be some tricky math in there if your algebra skills are not super. All right, so we had direct variation, we had joint variation, we had inverse variation, and now combined variation. Well, we can put these into word problems and see how they apply. So the first one here, the height that a diver leaps above a diving board varies directly with the amount that the tip of the diving board dips below its normal level. If a diver leaps 44 inches above the diving board, when the diving board tip dips 12 inches, how high will the diver leap above the diving board if the tip dips 18 inches? Use a variation equation. So let's see, in this problem, we have the height that the diver leaps and the amount that the diving board dips. So we have the height of the board, I'm going to call H, and the D is the amount that it dips. So if the height varies directly as the amount of the tip, then we have H equals KD. If the diver leaps 44 inches above, that's an H. And above the diving board, when the diving board tips 12, oh, that's a D. Oh, there's a pair. How high will the diver leap above the diving board if the tip dips 18? There's your other D. So it looks like I have a 44 goes with a 12, and then I'm looking to see what goes with 18. So let's use 44 equals K times 12 to figure out what my K is. So if I divide everything by 12 and simplify that fraction, I'm going to get 11 thirds. Then I'm going to take that and I'm going to write my new equation, H equals 11 thirds D. The other number that I'm given is a D. So H equals 11 thirds times 18. So my height is going to be 66 feet. No, not feet. Inches. Feet. 66 feet would be ginormous, Yanka. 66 inches. Okay, here's another one. Heart rates and lifespans of most mammals are inversely related. A cat lives for about 15.2 years on average and has a heart rate of 126 beats per minute. A hamster can live on average 3.1 years about how many beats per minute does a hamster's heart have, use a variation equation, round to the nearest beat per minute. So what we got, heart rates and lifespan. So let's do H is for heart rate and L is for lifespan. So they're inversely related. Doesn't tell you which one equals K, which one, but since they're inversely, it doesn't matter. So H equals K over L. I could also put L equals K over H. The point is that they are inversely related. So let's see, a cat lives, so that's an L. 15.2 years on average and has a heart rate, that's an H of 126. A hamster lives on average 3.1 years, that's my other L, and I'm looking for my other H. So 15.2 and 126 go together. So 126 equals K over 15.2. I can multiply both sides by 15.2. And I get a K value of 1915.2. So now I can take that and I can say H equals 1915.2 over L. I now have a hamster living 3.1 years, so H equals 1915.2 divided by 3.1. And it says around nearest beat per minute. When I divide, I get 618 beats per minute. Holy cow, that hamster's heart is beating fast. Crazy. All right, kids, that's the end of section 7.5. If you have any questions, please let me know. And as always, keep calm and keep trucking.